This video is on moments of inertia. Question 1. State the equation, define each variable and give the units for the moment of inertia I. What is a moment of inertia I equivalent to in translational motion? So recall the definition of inertia. Inertia is the resistance to change in motion. An object will not speed up, slow down, or change direction unless there is a net non-zero force on the object. Inertia is directly proportional to mass. And the more mass an object has, the more difficult it is to get the object to speed up, slow down, or change direction, meaning accelerate. So this is important. The moment of inertia has nothing to do with time. Don't get confused with the term moments, okay? So the moment of inertia is I. It's given by the equation kmr squared, where I is the moment of inertia of an object. K is a positive non-zero constant, depending on the shape of the object. M is the mass of the object, and R is the axis of rotation. So in linear motion, we have something called mass. In circular motion, we have something called moment of inertia. And for point objects, the moment of inertia around an axis is given by the equation sigma m r squared. So the moment of inertia I is the circular motion or angular motion equivalent to mass in linear motion or translational motion. Okay. So look at these four objects, M1, M2, M3, M4. They're all rotating around this fixed point where the lines converge. So the greater the mass an object has, and or the greater the axis of rotation, the more torque it will take to get the object to rotate, and therefore the greater its moment of inertia. Torque is like force. Force for linear motion is torque for angular motion or circular motion. Now this is why ice skaters with their arms out rotate slower than ice skater with their arms holding their chest. So if all of this mass was towards the center, the moment of inertia will be a smaller number than if all of the mass were going outside. So tables for moment of inertia for some objects are available for free online. Exams will give you the moment of inertia of an object when necessary, no need to memorize. Question 2. Determine the moment of inertia of three objects rotating around a point P. Treat the three objects as point masses. So we're just going to use this equation, sigma m r squared, and add them all up. So this is like the mass going around point P. Because remember, mass has units of kilograms in linear motion. Moment of inertia is like mass in circular motion, but it has units of kilograms meters squared. Question 3. What is a moment of inertia of a wheel shaped like a ring, which has a radius of 34 centimeters and a mass of 4.5 kilograms? The moment of inertia of a ring is given by this equation, mr squared. So we get this. Question 4. What is the moment of inertia of a 2.5 kilogram sphere which has a radius of 6 centimeters? The moment of inertia of a sphere is given by the equation 2/5 mr squared. So we get this. Question 5. What is the moment of inertia of a disk which has a mass of 4.4 kilograms and a radius of 45 centimeters? The moment of inertia of a disk is given by the equation this. This is our solution. Finally, the Earth has a mass of 5.98 times 10 to the 24 kilograms and an average radius of 6.37 times 10 to the 6 meters. Assuming that the Earth is a uniform sphere, which it is not, what is the moment of inertia of the Earth? So this.